All right, class, the quadratic formula, and we're also going to talk about the discriminant, which is a specific part of the quadratic formula. So here we go. Hopefully you remember this, but I always like to sing the little jingle. It's x equals negative b plus and minus square root b squared minus 4ac all over 2a. I think it helps. So hopefully that gets stuck in your head and you remember it as well. Okay, the discriminant is a specific part of the quadratic formula. It's the part that's underneath the radical sign. So b squared minus 4ac. It tells us how many solutions and what type of solutions we're going to have for a quadratic equation. Because if b squared minus 4ac is positive, then we're going to take the square root of a positive number, so then we're going to have two real number solutions. If the discriminant, the b squared minus 4ac part, is negative, then that means that we'll end up in the quadratic formula, we'll have the square root of a negative number, so that will give us two imaginary solutions. And then finally, if b squared minus 4ac is 0, then we'll take the square root of 0, which is 0. We'll have negative b plus 0 and minus 0 are the same thing. So you end up with one answer, and it's a real solution. So let's look at a few examples. So find the number of solutions by using the discriminant and then solve with the quadratic formula. So first, in order to solve with the quadratic formula, your equation does have to be equal to 0. So subtract 1 from both sides, so we get x squared plus 3x minus 1 equals 0. Because when you're solving for the value of x, you're actually finding where the equation equals 0, so where it crosses the x-axis, or where the y, because typically the quadratic formula is like y equals x squared, so when the y is equal to 0, where it crosses the x-axis. Those are our solutions. So I'm not going to do this for everyone, but in this one we have a equals 1, b is 3, and c is negative 1. So plugging into our quadratic formula, which again is x equals negative b plus and minus square root b squared minus 4ac all over 2a. And I'm not planning on quitting my job anytime soon and going on the road with singing, because I know I'm not great, but that's all right. So let's find the discriminant part first, the b squared minus 4ac. So b squared minus 4ac would be 3 squared minus 4 times 1 times negative 1. That'd be 9, and then that'd be plus 4, because you'd have two negatives, are going to make that a plus, and 4 times 1 is 4. So 9 plus 4 is 13, which means that I will have two real solutions, which means you will have two real x-intercepts, and this parabola opens up because the a value is positive. So that's just like a quick sketch. So the discriminant equals 13. So then inside, for find the x-intercepts, it's going to be x equals negative b, so negative 3, plus and minus the square root of 13, all over 2 times 1, so 2. So that is technically our exact answer. If we wanted a decimal approximation for this answer, we'd have to use a calculator. You'd have to say, okay, well, that's negative 3 plus the square root of 13, and that equals that decimal, then divided that by 2. One of our x-intercepts would be at 0.303 approximately, and 0. And then we'd have negative 3 minus the square root of 13, and then divide that by 2. And our other x-intercept is approximately negative 330.3030. For algebra 2, so these are maybe acceptable answers in algebra 1, having the decimal approximation, and I do think that it's worth finding those sometimes so that you can kind of visualize the x-intercepts. I guess my graph was a little bit off. It was more like this maybe. But in algebra 2, we do want to list our answers typically in exact form, which should be this. Or as negative 3 plus the square root of 13 over 2 and negative 3 minus the square root of 13 over 2 is 0. So that would be the more exact way to write it. Okay. So let's find the discriminant first. Here we have a is negative 1, b is 2, c is negative 1. So b squared minus 4ac would be 2 squared minus 4 times negative 1 times negative 1 again. So that's going to be 4. Since I have a negative, and a negative, it'll be minus, and then 4 times 1 is 4. So 4 minus 4 is 0, which means I will only have one real solution. And that kind of works like this. When you plug it back into x equals negative b, so negative 2 plus or minus the square root, b squared minus 4ac was 0, all over 2 times a, which would be 2 times negative 1. So the square root of 0 is just 0, so then you get negative 2 over negative 2, which will simplify to 1. So we're going to have one real solution, and in fact, that real solution is 1. X equals 1. Which means it has an x-intercept at positive 1. And this one opens down because the a value out front is negative. And so this one would look something like that. So that would be our vertex point, if you remember from graphing parabolas at all. Okay. We'll do at least one more. Here we have a equals 1, b this time equals 0, and then we have c equals 3. So our discriminant, b squared minus 4ac, is 0 squared minus 4 times 1 times 3 would be 0 minus, and then, so we only have one negative, so it's minus. 4 times 1 times 3 would be 12. So negative 12, which means that this will have two imaginary solutions. So in our quadratic equation, it'll look like this. X equals negative b plus and minus square root. B squared minus 4ac was negative 12 over 2 times a. So 0, negative 0 is just 0. And then the square root of negative 12, we can actually break that down, because remember that's the square root of negative 1 times the square root of 4 times the square root of 3. So square root of 4 is 2, square root of negative 1 is I, square root's of 3. So you actually have plus or minus 2i square roots of 3. Or you can remember to use the factor tree, 3 times 4 and 2 times 2. You can take out a factor of 2. And then because it was negative, it's imaginary, and then there's a 3 left over. So however you want to represent that breaking down of that root, but write it in simplest form. So then we have plus or minus 2i square roots of 3 over 2. And then since this 2 and this 2 are both on the outside of the square root, that can be simplified to plus or minus I square roots of 3. Since 2 divided by 2 is 1. And then square root of 3 divided by 1 is just square root of 3 still. So we have two roots. We have x equals I square roots of 3 and x equals negative I square roots of 3. This parabola is going to open up. The vertex is actually here at 0, 3, and it opens up like this. Since it has imaginary roots, it has no x-intercepts. So it never crosses the x-axis. That's kind of, that's what happens when you have imaginary solutions. Because the solutions are, otherwise, the real solutions are the x-intercepts. All right. It's probably enough examples, so you know, if you think you got it, you can stop watching here. If you want to see one more example, stick with me. This one, you do have to get the equation equal to 0 first, so you have to add an x to both sides, and then subtract the 8. So that'll be 5x squared plus x minus 8 equals 0. Then b squared minus 4ac would be a is 5, b is 1, and c is negative 8. So b squared would be 1 squared minus 4 times 5 times negative 8. So it'd be 1, and there's 2 negatives, so it's going to be plus. 4 times 5 is 20, times 8 is 160, so 161. Which means it'll have 2 real solutions. So then it's x equals, and sometimes instead of saying negative b, you can think of it as the opposite of b. Since if b is already negative, it would go in to the equation as positive there. So this case, though, it's negative 1, negative b plus or minus the square root of 161 all over 2a. Now, the square root of 161, I don't think that that is a perfect square, but it's late, and I want to make sure. Oh, darn it. Square root 161. Okay, I feel like 161 is like prime, maybe. Yeah, I don't think we can divide that by anything. So I think our answer is just going to be negative 1 plus or minus the square root of 161 over 10. If I'm wrong, you'll have to let me know. All right, there we go. So in this one, when you set it up, x squared minus 3x plus 7 equals 0, and you're going to put it in the equation x equals negative b. When you put in the negative 3, that's going to be a positive 3 out front when you plug that into the quadratic formula. So it's like the opposite of b plus or minus the square root, b squared minus 4ac all